In this explainer video, I'm going to be talking about the ice brick friction problem. My name is Graham Hatfield. The problem number 4 on the ExpertTA of forces between objects and friction. The question is a competitor in a winter sporting event pulls a 49-kilogram block of ice in the positive horizontal direction with a cable over his shoulder across a frozen lake as shown in the figure. Assume the coefficients of static and kinetic friction are as stated. I'm going to be focusing on the first problem, or the A, which says calculate the minimum force F he must exert to get the block sliding in newtons. So I'm going to be going over the free body diagram. This is the picture that's on the ExpertTA site, and this is the free body diagram. We focus the point on the block of ice and not the person. In the center of the block, we have going down is gravity, since we are on Earth and objects. We also have going north or up, we have the normal force of the ice block. Going to the left, we have the friction of the ice block going through on the ground. And then going towards the man pulling the ice block, we have the tension of the X and Y component. A lot of people will mess up by not realizing the X and the Y component and just putting one line showing that there is the tension of the rope or cable between the athlete and the ice block. How we find the net force equations X and Y. To get that, we needed to get all the forces for both equations, the X and the Y. We have gravity, the friction, and the normal force acting upon the ice block. But the difference between the X and Y is the friction of the cosine, or the friction of the sine, or the force of the cosine and the force of the sine, theta, per if you're talking about the X or the Y forces.